Signals and systems, signal operations, series on signals and systems, lecture number 1.16. A signal can be transformed, modified, or changed into another. The process, the procedure, the method involved is called operation. Folding, shifting, scaling, addition, subtraction, etc. These are all examples for operations on or between signals. Some of the just mentioned operations, they are performed on individual signals and some are performed between two signals. Folding, shifting, scaling, these are all examples for operations on individual signals, whereas addition, subtraction, multiplication, modulation, convolution, these are all examples for operations between two signals. In the present session, the focus is on basic signal operations we encounter frequently in the study of subject signals and systems. Let us move further to begin the session. A small introduction. A signal can be manipulated to transform it into a different signal by performing certain operations like scaling, amplitude scaling, shifting, flipping, time scaling like compression and expansion. One or more operations like addition, subtraction, multiplication, convolution can be performed between two signals to generate new signals. So it is, as already mentioned, about operations on individual signals and operations between two different signals. We consider first an operation shifting, time shifting. The signal x of t minus t naught shifts x of t to the right by t naught seconds if t naught is positive, and it shifts x of t to the left by t naught seconds if t naught is negative. Notice x of t minus t naught. This is same as x of t shifted right side, positive time side by t naught seconds when t naught is positive, and it is x of t shifted to left negative time side by t naught seconds when t naught is negative. Right shifting is delay, left shifting is advance. We frequently come across these terms, using of these terms. We encounter the terms delay and advance. Here he is giving a correspondence between shifting and delay, shifting and advance. Delay is a common practice in music from a CD or a tape, but time advance of real-time signal is not possible. Time shifting applied to periodic signal does not change its time period. This is an important aspect one has to keep in mind. So some basic facts, basic information, fundamental points pertaining to shifting is given in this particular slide. The impact of shifting is illustrated here in this slide. This is x of t. a sawtooth waveform, x of t minus t2 is x of t. Notice, waveform is the same. There is no change in the waveform. X of t minus t2, waveform wise, it is same as x of t. Difference is shift is there by t2 seconds, and the shift is rightwards, positive time side. Here t2 is positive. So x of t minus t2, it is delayed version of x of t. Another shifted version of x of t is also shown here. It is x of t plus t1. T1 is positive. Here also waveform is same. X of t plus t1 waveform is same as x of t. Only difference is shift is there. X of t is shifted leftwards negative time side by an amount equal to t1. As the shift is negative time side, it is called advance, time advance. So shifting is associated with delay or advance. Another operation is flipping. This operation is also called inversion, time inversion or folding. A signal x of minus t is flipping of x of t with respect to t equal to 0, and x of minus t plus t naught is shifting of x of minus t to t naught. So x of minus t is associated with only flipping, and x of minus t plus t naught, it is associated with flipping and shifting, both with respect to x of t. If x of t is positive time signal, then x of minus t becomes negative time signal. Flipping applied to periodic signal does not change its time period. In case of shifting also, it can be noticed, shifting doesn't change time period. Flipping also, it doesn't change time period of a periodic signal. Here is illustrated flipping operation. This is x of t, right side. Flipped signal can be seen on the left hand side, x of minus t. Notice x of minus t is mirror image of x of t. So flipping is basically mirroring operation, mirroring. Not only x of minus t is mirror image of x of t. X of t is also mirror image of x of minus t. This mirroring is with respect to t equal to 0. The distance of actual signal from the mirroring point is equal to distance of the image signal from the mirroring point, tau. So both sides it is tau. So in A you can see flipping operation. In B is shown flipping plus shifting. X of minus t is flipped signal, x of minus t plus t1. It is shifted version of x of minus t towards negative time side by an amount equal to t1. Whereas x of minus t minus t2 is shifted version of x of minus t on positive time side by an amount equal to t2. So this is a flipping operation, this is a shifting operation, both together are illustrated here. We consider another operation, it is called scaling. Scaling is associated with the two actions or activities. One is compression and another is expansion. Common name is scaling or time scaling. Time scaling is associated with compression. It is also associated with expansion. Time scaling is general term. Now let us see what is time scaling, what is compression, what is expansion. Signal x of at compresses x of t to 1 by a times if a is more than 1 and expands to a times if a is less than 1. Compresses x of t to 1 by a times. Compression means reduction in the duration of the signal. Expands to a times. Expansion means increasing the duration of the signal. It all depends upon value of a relative to 1. This process is called time scaling. Here a is multiplying with the time. Time scaling. This time scaling can be compression or it can be expansion depending upon value of a relative to 1. If x of t is an audio signal recorded on a tape, then x of 2t represents signal played back fast at speed equal to twice of the recording speed, and of t by 2 represents the signal played back slow at speed equal to half of the recording speed. Time scaling applied to a periodic signal changes its time period. Time scaling changes signal time period when it is a periodic one. One point we have to keep in mind is this is a time scaling. Amplitude scaling is also there. If a appears by the side of x, let us suppose it is a x of t, then it is called, that process is called amplitude scaling. Now we are discussing time scaling. A signal x of t with a time periodicity of t and a fundamental frequency of omega naught, when scaled to x of at, becomes periodic with the period of t by a and fundamental frequency of a omega naught. These 2 points, they are about the impact of time scaling on periodic signals. First one says time period changes. With the time scaling, naturally frequency also changes. How time period changes? It becomes t by a. How frequency changes? It becomes a omega naught when time scaling is by a. Now time scaling is illustrated. Compression, expansion, both are illustrated here. X of t, this is original signal. X of at, you can see it is expanded version of x of t. Of course, this expansion duration is more here. This expansion happens only when a is less than 1. When a is more than 1, compression takes place. Duration of the signal x of at, it is less when compared to duration of x of t. This compression happens when a is more than 1. Both, of course, belong to the category of time scaling. Another set of operations, multiplication and addition. Notice these operations belong to operations that can take place between 2 signals. The multiplication and addition operations on signals are to be carried out at every time instant, generating new signals. Another operation is also being mentioned here, modulation. Modulation is also an operation that can be done between 2 signals. Multiplication of a signal x of t by cos omega ct It is called modulation. The signal x of t is called modulating signal. Cos omega ct is called carrier signal. X of t cos omega ct, the product is called modulated signal. Omega c is called carrier frequency. If the multiplication is between two arbitrary signals, then it is simply multiplication. But if the multiplication happens between a signal and a cos omega ct, then the multiplication is called modulation. Modulation is a key operation, basic operation, fundamental operation in electrical communications. Signals sent out by radio or television stations are all modulated signals. Combined operations. So far, we mentioned only single operations, individual operations. Now, one can do several operations together on a signal, on an individual signal, or between two signals. First, we consider combined operations on a single signal, individual signal. The signal x of at minus t naught. Here, notice x of at minus t naught. It is a transformed signal. It is a modified signal. Original signal is x of t. From x of t, x of at minus t naught is obtained. It involves scaling. At is there. Time scaling is there. Minus t naught is also there. It means shifting is also there. Scaling and shifting. In this slide, some clarity is being given. How to obtain x of at minus t naught from x of t. There are two ways. One way is by first time shifting to obtain x of t minus t naught and then time scaling. First time shifting and then time scaling the shifted one to get x at minus t naught. Second path is first time scaling to obtain x of at and then time shifting the scaled signal by t naught by a to give x of a t minus t naught by a, which is of course x of at minus t naught. If a is negative, time scaling involves time inversion too. So this particular modification of signal will come very frequently. That's why it is being mentioned specifically here. How to get x of at minus t naught from x of t. Another example for combined operations is convolution. Convolution is an operation. It is performed between two signals. It is widely used, highly popular, and study of signals and systems cannot be complete without the study of convolution. Here it is being mentioned. It is widely used in modulation theory and it involves four operations actually. What are they? One is folding, another is shifting, in addition multiplication and integration. Folding, shifting, multiplication and integration, all the four operations are there in convolution. Now, in this slide, a procedure is illustrated to obtain x of at minus t naught from x of t. As already mentioned, there are two ways. First way is time shifting first and then scaling. Second procedure is scaling first and then shifting. In the first diagram, this one, shifting is done first and then scaling next. X of t is given and it is shifted, time shifted. Now x of t minus t naught is available. Now scale it, time scale it. If a is less than 1, expansion happens and it gets shifted rightwards towards positive time side. If A is more than 1, compression happens and it gets shifted leftwards, that is negative time side. This is one way. First time shifting, then scaling. Another way is also mentioned. First time scaling and then shifting. X of t is shown here. Scaling. Scaling may result in expansion or it may result in compression. If A is less than 1, expansion. If A is more than 1, compression. So in A, we have time scaling, time scaled signal. Then we can shift. The shifting is by an amount equal to T naught by A. If the case is A less than 1, expansion happens, and then when it is shifted by T naught by A, then the signal that is shown on the right hand side in B results. When A is more than 1, signal gets compressed, and when this compressed signal is shifted by T naught by A, then the signal that is shown on the left hand side in figure B appears. So shifting first, scaling next, scaling first, shifting next. Both the methods are illustrated here. These are some of the things which I want to share with you in the session. Before closing, let us recollect important aspects that are discussed in the present session. Operations are meant for transforming individual signals or generating new signal from two different signals. Scaling, shifting, multiplication, addition, subtraction, convolution, these are all operations, signal operations, which are performed, which are used to modify, to transform, to generate signals. All these aspects are touched upon and explained briefly in the session. We meet again in another session with another topic soon.